Let us look at proposition number 14 of Works of Archimedes. More specifically, book 1 of On the Sphere and Cylinder. The proposition says the surface of any isosceles cone, excluding the base, is equal to a circle whose radius is a mean proportional between the side of the cone, that is a generator, and the radius of the circle, which is the base of the cone. Let's understand this. Let A be the base of the cone. Draw C equal to radius of A. Draw D equal to the slant height of the cone. So slant height, or what is called as the generator, is this, the length of this line segment. Find E equal to the mean proportional between C and D. So which means C is to E is equal to E is to D, because E is the mean proportional between C and D. Now draw a circle B of radius E. What the proposition is saying is that the area of the circle B is equal to the area of the cone excluding the base. More specifically, the surface area of the cone excluding the base. So let's prove this. Let area of the cone excluding the base be S, assuming B is less than S. That is, the area of the circle is less than the surface area of the cone excluding the base. So which means we are using proof by contradiction. We are assuming that B is not equal to the area of the cone excluding the base. So first case would be less than. So we circumscribe a polygon about B and inscribe a polygon in B such that its ratio is less than S is to B. Now we circumscribe a polygon about A similar to the circumscribed polygon about B. We set up a pyramid on the circumscribed polygon about A with the same apex as that of the cone. We know that polygon about A is to polygon about B is equal to the C is the radius of this circle, that is the base of the cone, and E is the radius of this circle, B. So these polygons are in duplicate ratio of the radii of the circles on which they are circumscribed, which means polygon about A is to polygon about B is equal to C is to D. Since C, E, D are in continued proportion, that means C square is to E square is equal to C is to D. Now polygon about A is to polygon about B is equal to polygon about A is to surface of pyramid excluding the base. So the ratio between the polygon about A and the polygon about B is the same as the polygon about A is to surface of the pyramid excluding the base. So which means surface of pyramid excluding the base is equal to polygon about B. Polygon about A is to polygon about B is equal to C is to D, and polygon about A is to polygon about B is equal to polygon about A is to surface of pyramid. So that means polygon about B and surface of pyramid, they are both having the same ratio with polygon about A. So that means surface of pyramid excluding the base is equal to the polygon about B. Polygon about B is to polygon in B is less than S is to B, which is how we constructed it. So which means surface of pyramid is to polygon in B is less than S is to B, because polygon about B is equal to surface of pyramid, which is not possible. Since polygon in B is less than B, an inscribed polygon is less than the area of the circle in which it has been inscribed. And surface of the pyramid has to be greater than S for this inequality to be true. But we know that the circumscribed pyramid's surface area cannot be greater than the surface area of the cone on which it has been circumscribed. So therefore, B is not less than S. So now let's look at the other case. Other case is assuming B is greater than S. So again, circumscribed polygon about B is to inside polygon in B is less than B is to S. So that is how we circumscribe the polygons. Circumscribe and inscribe the polygons. Now inscribe in a polygon similar to the inscribed polygon in B and construct a pyramid on the polygon in A with the same apex as that of the cone. So which means polygon in A is to polygon in B is equal to C square is to E square. The inscribed polygons are in duplicate ratio of the radii of the circles in which they have been inscribed. Or we can say polygon in A is to polygon in B is equal to C is to D. Again, because C, E and D are in continued proportion, and we know that C square is to E square is equal to C is to D. And we know that C is to D is greater than polygon in A is to surface of pyramid excluding the base. Remember, C is the radius of the circle A. D is the slant height of the cone. And the surface area is dependent on the height of the cone. That is the perpendicular drawn from the apex to the circle. That is the base. So C is to D is greater than polygon in A is to surface of pyramid excluding the base. So which means polygon in A is to polygon in B is greater than polygon in A is to surface of pyramid excluding the base. So which implies surface of pyramid is greater than polygon in B. Now how did we arrive at this? Polygon in A is to polygon in B is greater than polygon in A is to pyramid surface of pyramid. So here surface of pyramid and polygon in B are both are being compared to the same figure, that is polygon in A. So therefore surface of pyramid is greater than polygon in B. Or we can say, since the numerators are both equal, that means the inequality is determined by the denominators. So which means if this ratio has to be greater than this ratio, surface of pyramid has to be greater than polygon in. But we have already seen that polygon about B is to polygon in B is less than B is to S. So polygon about B is to surface of pyramid is less than B is to S. Because polygon about B is to polygon in B is less than B is to S. But polygon in B is less than surface of pyramid, or surface of pyramid is greater than polygon in B. So if the denominator of the left hand side is increased, this inequality stays. So polygon about B is to surface of pyramid is less than B is to S. But here polygon about B is greater than B, because this is a circumscribed polygon about B, which will always be greater than the area of the circle in which it has been circumscribed. And because of this proportionality, we have surface of pyramid is greater than S. But can the surface of S inscribed pyramid be greater than the surface area of a cone in which it has been inscribed? No, it can't be. So, since the pyramid is inscribed, it is not possible. So, therefore, B is not greater than S. So, since B is neither less than nor greater than S, it means B is equal to S. So, we have proved the proposition which says that the surface of any isosceles cone excluding the base is equal to a circle whose radius is a mean proportional between the side of the cone and the radius of the circle, which is the base of the cone. So that is proposition number 14 of works of Archimedes, more specifically on the sphere and cylinder. Book 1. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.